This week and possibly next week, we're going to be talking about our Markdown. We have some learning objectives, basically creating the R Markdown documents, formatting the text, code chunks, using some chunk options and making tables look pretty, caching data, and other ways to put code and format code into your document. So the intro is basically just, data science doesn't really mean anything unless you can communicate your results with others. And so R Markdown is a tool for integrating prose, code, and your results. So you can have notebook mode for talking to your peers, and you can have remote mode or report mode for talking or communicating with decision makers. But then you can also use the same documents for both purposes. And RStudio automatically installs and loads the R Markdown package, so you don't need to call anything specific. And the basics of R Markdown, it's a file that has the extension .R_md. Usually starts with YAML, yet another Markdown language. And you can see that at the top here, just surrounded by the dashes. And then you have code chunks, which we'll take a look at, and then you have text.
Sorry, can I ask a question? What is, okay, so I've worked with YAML files to specify specific environments. So what usually does a YAML file contain? So in this case, it looks like it's just, the title and header, but.
Yeah, so we are going to talk a little bit more about YAML further in the chapter. However, I'm not sure exactly what the files contain, like what the structure of the files are. So yeah, when we get to parameters, there's certain things you can put in there. Where's that?
Okay.
Oh, the citations. That's what it was. So you can call files like an R Markdown bib, which is a file that contains formatting for your bibliography. But again, I don't know like what the structure of that file looks like.
Right. Okay.
To give a quick synopsis of YAML, Becki, not to take away from the presentation. So YAML is just another format of file output. So if you think about XML, if you think about HTML, if you think of JSON files, all of these formats, these syntactical formats of file structure, YAML specifically is tab delimited, and it takes a very reminiscent sort of JSON-esque appearance, other than it's missing the semicolons. What YAML is specific is a lot of the Linux distributions into the future. I think it's Ubuntu 2004 and maybe beyond. They switched their network manager to being more YAML formatted instead of the previous configuration file set. In Kubernetes or Docker containers, it uses a lot of YAML files for instruction to the runtime environment. In HTML, you've got your preamble, the doc file, HTML, and then whatever your head, body, paragraph tags, etc. So the concept behind a YAML structure is nothing more than tagging information so that the runtime environment can grab that piece of information with the populated variable and then use it within the context. So the YAML header in this Markdown format is at the very top of your file, the RMD file. It gives instructions to other services on how to manage this format. So if you have like your output, as an example, in Becky's point, output is HTML notebook. So when you knit this together, or Bookdown or any other compiler, this is instruction to that service that is going to render it in the output side. So I'm sorry, that was a long explanation of YAML, but it's really just a format of information. It's a type of format of information.
Got it. No, that was an excellent description, Ryan. Thank you.
Okay, to produce your report, you can click knit, which is up here. You can hit Command or Control + Shift + K, or you can actually put in code in your document to do that. When you knit the document, R Markdown sends the .rmd file to knitter. And I hope I'm saying that right, or is it knitr? So the knitter package was designed to be a transparent engine for dynamic report generation with R, and combine features in other add-on packages into one package. So it collects a bunch of things to make your work easier. Knitter executes all of the code chunks and creates a new markdown.md document, which includes the code and its output. And then that MD file is processed by Pandoc, which creates the finished file. And Pandoc is a universal document converter. There's a massive diagram on the website showing all of the different formats it converts between. So it kind of seems like it pretty much does every possible file format you could want. And because this process is 2 steps, it gives you more options over your final output formats.
Sorry, can I ask another question? So what does a document converter actually do?
So it would convert between like a PDF and a .pdf and a .doc, or a .rtf to like .html. Like it converts. Yeah, it's just a converter.
Okay, so it's between different file formats?
Yes.
Not necessarily documents, or am I missing something?
Well, actually, let me see if I can get to Pandoc. Okay, so it is a document converter. So here's that diagram I was talking about. Okay. So yeah, it can just go between yeah, any of these formats, and I can show you this. Yeah, so this can go between all of these things, and yeah, there's a lot of lines.
Can you scroll up, Becki?
Sure.
So to wherever the document or the page header was.
On the in RStudio? Okay.
No, in this page, just all the way up, please. Thank you. Okay, so it's for markup format into another format, I guess. Okay.
I like to think of Pandoc as like a Swiss Army knife of translation. So the idea behind the under the engine concepts of Pandoc, it's reading and interpreting a particular code base or file format, like that YAML file or XML or LaTeX, RMD files, Markdown files, etc., and then transposing that information into another format that can be saved and opened in another program. So the comment of like any other translation engine, I'm going to use Frederica if that's okay. So Frederica is in Italy, right? And her probably native tongue is Italian, but she speaks English. And so the concept behind switching back and forth between those 2 languages your locale or your lexicon, but it's your language translation. So pandoc is really at the cornerstone of being able to take one file format or one information format and then producing it into another format.
Got it. Okay. And sorry about this extra question, I guess, but how in a computer, how do you specify a file format? What is different between different file formats? Is it like the encoding? Is it like how you allocate memory or?
No. So it's actually
Okay.
an association of program to render or to interpret that information type with. So like as an example, if we say Markdown MD files, well, a Markdown file can be viewed and interpreted by a browser, by a text editor, by RStudio. What you're doing is on the underside of your computer is just associating that file format with a program that can read and interpret it. Sometimes you'll get that pop up depending on if you're on Mac or Windows, but you'll get that pop up and say, what program do you want to open this file format with? If it's not recognized, then you can have a selection of, choose this program to ingest and interpret that type of information with. So.
Right. I guess I just had like maybe a deeper question in terms of, why there are different file formats, why they are necessary, or you know what I mean? It's sort of a not asking. Okay. So if you get down to like bits, right? What is different between file formats in the way that they handle, like, like the binary, but we don't have to get into that. Sorry, I can probably just, for my own sake, move on, let Becki just finish, and then we can come around at the end if there's time. Okay. Yeah.
Yeah, that's above my pay grade. So Markdown has text formatting, and it's a lightweight set of conventions for formatting plain text files. And this example below uses Pandoc's Markdown, a slightly extended version of Markdown that R Markdown understands. And so for me, as someone who is still learning this, switching between this visual editor and the source editor is super helpful for me learning this. So this is what we were just looking at. There's line break, there's italics and bold, headers, lists, and a table. And again, this is what it ends up looking like. And so in this visual editor, it's pretty easy to insert things and like insert a table. So I'll do something like insert a table, and I'll switch to the editor view and figure out how to just type in a table. Code chunks. So a code chunk should be relatively self-contained.
I have a question.
Oh, sure.
Sorry. Yes, please go up. Where you added a subscript. Yes, this.
Oh.
Yeah, so I am actually learning that you can add such on a text and not just the formula. Because if I look at this, looks like a text, right? Okay, all right. Okay, thank you. I was just confirming that.
Oh, yeah. So this is yeah, superscript and subscript.
So for sub, use the tiled. Okay.
Yeah.
All right. Okay, thank you.
Yeah, see, it's a good way to learn. Just switch back and forth between the two.
Yeah.
Okay. So code chunks can be inserted 3 ways. You can do the keyboard shortcut, the Command or Control Alt and I. You can use the insert button. Again, that's up here. And then you can manually type in the chunk delimiters, which are the triple thing under the tilde mark. I can't, is there a certain word for these?
Backticks.
Okay,
Backticks.
thank you.
Yep. A single backtick is only commenting one string of text, where a triple backtick is
the code
indicating a
chunk.
code block. Yep.
Yeah.
Yep.
You can run code by clicking the arrow, which is this arrow here, to run the code chunk line by line. You can use command control or control plus enter, or if you want to run the whole thing, control shift enter. So yeah, this is not going to work today. Chunk names. You can see in this chunk up here, it's been named R pressure. And the reason to name your chunks, you can use a drop-down menu in the lower left to find them. So just down here where it says chunk 1 pressure, you can scroll through and look at your chunks. Graphics will have useful names. It's easier to use them elsewhere. And you can set up networks of cached chunks, so you don't have to keep rerunning expensive code. And so as you can see up here and down here, names are formatted with inside the curly braces, the space after the R, and the name. Setup is a special name, and the code chunk will run once before any others in notebook mode. So that's a good way to kind of set things up before you get going. And there are several chunk options, so you can control what does and doesn't show. There's eval equals false, prevents code from being evaluated. So if you have example code and you don't want to see the results, include equals false runs the code but doesn't show the code or the results in the final document. And again, that could be for your setup code. Echo equals false prevents code but not the results from appearing in the finished file. It's for presentations with people that don't care about code, like maybe managers. Then we have message and or warning equals false. Those prevent messages or warnings from appearing. And then you can hide your printed results, and you can hide your plot results. And then there's just this table. These dashes show what is suppressed. So the only thing that eval equals false will do is show the code. The only thing include false will do is run the code, and etc. Error equals true causes the render to continue even if the code returns an error. Probably not something you want in your final report, but useful for debugging or teaching. The default error equals false causes knitting to fail if there is a single error in the document. And I've actually was trying to knit this all week, and it was not happening.
Yeah, I'm having a similar problem on just book down, knitting together the entire R4ds community that we've been working on for months now.
Yes, me too.
Yeah.
Oh,
Yeah.
There's
Phew,
you're
I'm
not
not
alone.
the only person.
No, John and I have been trying different ways of installing all the dev tools and installing all the packages just to try and get the output to knit together, and it's not playing nice.
Okay.
But
I'm not
okay.
going to sweat this then.
Yep. No, you're not alone.
Okay.
I did want to add something to the code chunk real quick that wasn't specified in the document. So the entry point of that code block with R having the entry, that tells the compiler use R syntax to populate or to render it. That's where you get that really awesome kind of color output of when you compile into that HTML output. If you change that to any other common language, it will also render or use that, Pandoc will use that call to render it in the format of that language as well. So if you're doing JavaScript or Python or Ruby or any other scripting language, that first entry call will actually render it in the format native to that language. So something that most users of RStudio probably don't realize that that's possible.
Sorry, Ryan, what are exactly you referring to?
So
setup?
Becki, yep. So
This-
Becky's got the, go ahead, Becki.
Oh, so this R that's highlighted, when you type in a code chunk, like R pressure, you can actually change this R for like Python or something else, and it will run that code in Python. So you can
Right,
actually,
and that was called the setup line, setup chunk.
no, this is just how you specify code chunks. So this, like when you insert a code chunk, actually, let me switch to. So like here, when you insert a code chunk, you've got the backticks and then the R in the curly braces. This is just saying that if you replace this R right here with another programming language, like Python, or I guess like C++, like does anything work? Instead of this code being in the R programming language, you could have it in the Python programming language, and it would actually run that code chunk in Python.
If you have the kernel installed, or if you have the
yes.
compiler installed, yeah.
You have to have everything installed to make it work. Does that answer your question?
Yeah, no, I was just
Okay.
wondering what the name of that was, or if it had a specific name.
It's
yeah.
What's actually inside the curly braces.
Yeah, or if that curly braces language has a specific name. But no, never mind. It's not important.
Okay. So in theory, you can prettify a table with knitr. Absolutely nothing is working today. This is awesome. Cannot read property of style of undefined. Okay. Is this gonna work here? Wow. Okay. So this is not working. There it goes. Geez. All right. So when you show a table in R, you get something that looks like this. And sometimes like the values will be cut off, and then you have like double up here, which just shows the type of value that is in that column. You might not want that in your final report, and so knitr creates a table that I have to say doesn't quite look as good as the table above, but it will always include all of the information that you want, and it will not be truncated. And it also doesn't tell you what the values are in the column. So like if you're presenting this to, again, someone who's not a statistician or data scientist, they won't be asking you like, what does this DVL mean? Okay, yeah, so here you can see like some of the values are truncated, and this table is still showing up with all of the values. And I'm assuming that with this cable, you can specify like how much space you want between columns. And so for more customization, you can check out the help files on cable. And you can also look at these packages that were mentioned in the book. And we will learn about options for controlling how figures are embedded in the next chapter. Okay, so sometimes your code will be expensive or it will take a long time to run. And normally each knit of a document starts from a completely clean slate. So it's great for reproducing things, but not great for the computations that do take a lot of time. So what you can do is use cache equals true. And this saves the output of the chunk to a specially named file on disk. And I'm not sure what that file is named, if it just creates a name. Do you know, Ryan?
I think it's just in your environment. So while
Okay.
while our studio is running, obviously there's memory allocated to the operations of that program. It generates a unique file name for that storage so that when it does compile it or whatever output you have, it's already built that reference. It already knows where it's at and it can pull it in. I think I'm pretty sure
Okay.
that's the
That
statement.
makes sense.
This comment comes up quite a bit in a lot of our tiny modeling with R. It comes up a lot in our mastering Shiny, ggplot. There's references to these unique file names. The only association I can make thus far is it's just a memory allocation or something under RStudio or under any worry that you have as a developer or an author. Just know that it's being managed by the program itself.
Okay. So on subsequent runs, Knitter will check to see if the code has changed, and if it hasn't, it will just reuse the cache results from that file. Be careful using caching. It's based on the code, not the dependencies. So for example, we have a code chunk named raw data, and it is basically just reading in a very large CSV file. And then we have a code chunk named process data, which is where we're actually doing stuff with the things and using cache equals true, because again, it's a very large file. But if process data is changed, it will get rerun. If the read CSV call is changed, it won't. So to avoid that, you use the depends on chunk. And I call this process data 2, but just ignore the 2 because it's supposed to be the same thing as previously looked at, but it was one of the things that was preventing the document from knitting. It didn't like having 2 code chunks with the same name. So we've added depends on raw data to our code chunk. So now this process data code chunk, like it knows that it depends on the raw data code chunk. But the chunks still won't update if the actual CSV file changes. So in that case, you can add cache.extra to the CSV chunk. And again, ignore the 2 here. So we have raw data cache extra file.info with the very large CSV file. So if that changes, then it will rerun everything that depends on it. If you do cache a lot, you can clean it out regularly with the Knitter clean cache. And again, with the naming chunks, if you name the chunk after the primary object that it creates, it makes it easier also to use the depends on command. So you can also set global options for your chunks when you want more flexibility. So say we're preparing a report and wanted to hide all of the code, but show
Please allow me to ask a
results.
question before you go to the global options. Yeah. This depends on a chunk. So it has, I'm assuming it has to have, you must be executing one task for that particular chunk for you to move it to, like, to carry it forward to the next chunk. Or I think I'm lost here.
Are you talking about the caching that we were just talking about?
They depends on, yes. This
Okay.
depends on, yeah.
And I'm sorry, where was the confusion coming in?
Yeah, I'm trying to understand its purpose. So the previous chunk, you had named it raw data, and this is when you called in, you imported the data, and then now you want to use that.
So this code chunk, the process data depends on what we're getting out of, it depends on raw data, which is what we're getting out of the CSV file. And I apologize, my internet connection is apparently unstable right now. So then we do some stuff with the raw data. But if we change this code with that we've cached the results, it will notice that and it will actually rerun the code instead of not rerunning it. Is that making sense so far?
Yes, it's clear now. Thank you.
Oh, okay. Okay, so for global options.
Sorry, Becky, I guess just one question. So it's always faster, I'm guessing, because they're talking about this caching thing, to compare something to a previous version than rerunning a very long computation. Is that the case?
It seems like it. It seems to me that would take a lot less.
That's interesting.
Memory.
Yeah. Huh.
Do you have any input, Ryan?
Yeah, I'm thinking on if that's actually the case. So that comparison concept, Sandra, it's not like a line for line comparison from one code base to another code base. I believe what we're looking at is like almost like a CRC or checksum of that code block. And if the data contained within that temporary file is different from what would be computed, but that's not that, you'd have to compute that to figure out what that output would be. Anyway, my point being is that a comparison logic of rendering a second time over versus cached, this gets into kind of like Redis servers and other cached type manipulation. You're not re-rendering the code base all over again. It's a quick look. Is this different than what I previously have stored? If it is, go ahead and render it again. If not, continue on and we'll just use the cache media.
Right. So
yeah, go ahead.
What is the difference then between caching and just saving an object, or
temp,
you know what I mean?
Temp files, it's non-persistent. So caching is like non-persistent memory. Think of it as like storing in RAM. If you restart your computer, close the program and restart, you're going to have to re-render all of this again to populate that cache media.
Okay, but then what's the point of doing it in a markdown if you're going to knit, from a clean slate? So if it's cache, wouldn't it be gone after you close that, original?
It would be if you're in the midst of populating your document, writing some content, and you run a very exhaustive form of calculation. Let's just use like a Frederico, what's a really costly tree form, maybe neural network form of rendering, and then you've got your output. Well, do I want to render that 10, 15 minutes worth of time or 2 hours worth of time every time I open this file? Probably not. Let's just use the cache media instead. We've already spent the time and populated that calculation. We don't want to render it a second time over. I'm thinking in this idea of this caching concept of I'm in the midst of authoring it. I've already ran that code block. It took me 15 minutes to render it. I don't want to render it again. So by adding that cache value of true, go ahead and store whatever output I have. So the next time I knit the document together, while I'm in this environment, if I knit the document, it's just going to pull from that cached media instead of rendering it again.
But I guess my question would be during that session.
Yes. Yes, that's correct.
Okay.
Yep.
Okay. Thank you.
Okay, so global options, you can set those in a chunk of code so that this echo equals false applies to all of your code chunks throughout the entire document. Another way to embed our code in your R Markdown document is, okay, let's switch again, is using the backtick R backtick right in the middle of a sentence. And just ignore this code. So we had, this is an example of, thank you, I know my internet connection is unstable. This would be an example of a sentence that you could put in a document. Say we have data about backtick, run this little tiny bit of R diamonds, only R and row diamonds minus and row smaller are larger than 2.5 carats. And then when the report is knit, the results of these computations are inserted into the text. So your results are in the resulting document, you would have this sentence instead. And there are, the author put in some examples of inserting numbers into text and how to format those. Format allows you to set the number of digits in a number, and then big dot mark allows you to delineate your numbers with either commas or periods. Let's see if this code chunk runs. Nope. Go back. Inline. There we go. So you can see this inserted commas so that you can easily tell that's 3 million, and then this just truncated the decimal number. So troubleshooting, I did a little bit of this this week trying to get this document to knit. It's unfortunately unsuccessful, but you can try recreating the problem in an interactive session. Restart R, then run all chunks. You can check your working directory with get working directory in a code chunk, and make sure where you think you're saving and where you're getting the files from are like what you expect. And then you can brainstorm what might cause a bug and systematically check those things. So the YAML, you can control document properties in the header. And you can do a couple things. You can use parameters, and these are useful when you want to re-render the same report with distinct values for various key inputs. So like you might have sales reports for each branch of your company, exam results for each student, or demographic summaries by country. So the parameter command is this params, and then you can specify the parameter that you want to change, right? So in this, we're looking at the MT cars, but we're only looking at the SUV class. And so this would be what we change, like if we wanted to look at sedans, we could just put sedan in here and rerun this code, and this params my class would pull whatever value you've put into put in right here. And you can write atomic vectors directly into the YAML header. You can also run arbitrary R expressions by prefacing the parameter value with an exclamation point. And this is a good way to specify date time parameters. So again, you have the parameter command and you have a start and a snapshot here. And I wasn't sure what this would do. Like why this would be something you'd want to include in your document.
Can't confirm. I can't ensure that I'm stating this correctly, but the exclamation point and then some language, often the word parameter is what I'm kind of struggling with in the context of the paragraph. So normally Markdown is going to be rendered in some other format. So you've got it in one, R Markdown renders to Markdown, Pandoc renders it to whatever output you're commanding it to output in. For example, HTML, a anchor tag or some kind of a reference tag pointing you at some other location of where this media is stored. I don't know if the use of the term parameter is accurate in the thought that I'm conveying here with this reference to another location. I don't know. Have we glazed over the image references yet? So like if you've got a image library and within the Markdown document, you're pointing at that image and say, I want to render this into that output. Again, I'm using HTML as my example, or if it's PDF, whatever the case is. So it's taking that image with that exclamation point, square brackets, namespace reference of where it's located, and then pulling that into the compiler on its output side. The word parameter is what I'm having difficulty with.
That's what
it's
I'm having
vocabulary
difficulty
term
with too.
Yeah, well, and it may be in the nature of how the RStudio or Markdown package is written, the vocabulary term parameter in its use. I run into this often within a lot of our documentation, our documentation. They'll use a vocabulary term, but it also implies there's an alias to some other protocol term used in another language. I want to make that link so that I can convey exactly what that term implies.
Okay. So there is an option to knit with parameters. Don't quite understand what that is. It's right here. And again, I had just errors galore when I tried to do that. But it will set the parameters, render, and previews the report in a single step if it works. Or you can call the R Markdown render with a list of parameters as such right here. So that's basically the parameters that we had up here.
Just a thought, Becki, possibly.
Yeah.
I'm gonna use a different term, but it's implying the same concept. So in a lot of our arguments that we write, this equation that we're formulating to run an equation, a parameter would be like a placeholder of information that you want to plug into that. So I'm going to use the term variable instead, and variable is just a placeholder. It's a reference to information. So I'm putting this placeholder in here because I really don't know what we're going to put in there. I just need to have a bookmark that whatever I tell it in the code, go ahead and put that parameter in there to render the rest of the equation. I'm thinking maybe this parameter thought process is just a placeholder of an equation.
Okay. That makes a
Yeah.
little bit more sense. Okay, you can also have bibliographies and citations in your document and format them or generate them. Pandoc can automatically generate citations and a bibliography in a range of styles. So I was also a little confused with this. So the call to the bibliography would contain the path from the directory that contains your .rmd file to the file that contains the bibliography file, and that doesn't appear, there doesn't appear to be a path here, but I guess, does it just pull from your environment? Or
You would have a bib file saved that would have all your citations so that it's
like in
reading.
the same directory?
Yes.
Okay.
So there's many tools to author bib files. I can't remember Medela. There's a tool that I used quite often, and I'm hoping Sandra in the academic world may jump in and help there too. But you're referencing in certain formats the bibliography or references. There's another citations section. This bib file has all of those references, the time that you viewed the file, the link that it's located, the library reference, the, et cetera, so that another researcher can also follow that citation and read your interpretation of what you were calling on.
Okay.
Yeah, I think I've only used this bib file, but not as a standalone. Usually there are reference managers, and almost all can read this bib file, so that when you either download or transfer from one reference manager to another, it's that format, I think. There might be others. I'm not entirely sure.
Okay. So the basic format for creating a citation within your R Markdown file, use a key composed of the @ sign and then the citation identifier from the bibliography file. In this case, it would be that. And then place the citation in square brackets. And so this separates the citations with a semicolon. You can use dashes. There's a format where you don't use the square brackets if it's like inline in the text. There's several combinations that you can use. And when knitting, R appends the bibliography to the end of your document, but there's no header. So you can try ending your document with either this number sign indicates heading 1, so you can end it with references or bibliography or whatever you'd like to call it. And then finally, you can learn more at the R Markdown Studio. Kind of a fancy website, which I just realized you're probably not going to be able to see because I'm not sharing that part of my screen. And then the author also says, and you can use Git and GitHub. That is just a very collaborative platform where you can share code and markdown files and reports. Also, the author suggests improving your writing. That's always good for communication, and he recommends a couple books and an article online. And I just want to show this because this is a file that does actually knit. So this is like the generic R Markdown file you get when you create a brand new .rmd file in RStudio. So you can preview your notebook and you can see it does look much better than what we can see there we go. What we can see on the left. So I did actually get something to it. Okay, so we do have a few minutes. Did you want to circle back around, Sandra, about was it either the YAML or the caching that you were
Yeah,
what-
if you guys don't mind.
wanting the
I don't want
computer
to get kicked out of the group for annoying
description?
questions and, you know, like off
Well,
target.
The answers are always really interesting. I mean, maybe not related to what we're learning, but I always find them interesting. So
Okay.
well,
I think that's
related
just
to what we're learning.
right. Sometimes I think that's just how my mind works. Like I need to go into the details, or then I feel like I really don't understand things
Right.
properly. So I was looking into the cache, and Ryan, so you can of course correct me because I know nothing about this, but just comparing, say, to like a browser page, right? So cache pages or history or whatever gets stored on your physical device just as a different type of memory, right? So it's faster access, faster than RAM, but it is physically stored in your device so that next time you open your browser window, it's faster for loading, right? So
Right.
apparently like images. So I'm guessing for this caching in the Markdown, it must get physically stored more permanently somewhere so that you can reuse it, so that every time you open, like say, you know, a specific Markdown file, you don't need to rerun
Right.
that specific thing. Because otherwise I'm just like, it wouldn't make sense, you know, for that session, and then next time you have to do it again.
Right.
But that would just mean you need sufficient cache memory to store all of these if you have very large files, or maybe it doesn't take up a lot of memory once it's stored that way.
The comment I was making to Sandra in reference to this caching idea would be the whole concept of the R Markdown package or book down package, anything data science oriented is just that collaborative effort. So you're authoring a media presentation, R Markdown book or book down, whatever the case is, and you want to share it with others. You've already incurred the cost of generating that equation or that output, storing it. The statement I made to Sandra was, when you commit to version control, I want to look and find out, is that also saved in version control as well? Is that cached object that you've just rendered created and then lobbing it over to some other user that says, you know, cache equals true, is that other user's computer accessing that data that was just also downloaded as well? I don't know that for a fact. So the whole caching concept is not touchable by a user, meaning that we're not giving it a unique file name and a location where it's stored. It's all kind of managed in the background. That temp directory, and I'm remembering Colin Burke in Mastering Shiny. We ran some media. We were talking about web browser caching, and he went into his terminal and was able to pull out this object that he rendered, and it was just some gibberishy hex file name, but it was in a temp area of his computer. And he's like, yeah, this is the same thing. That's what I'm kind of thinking in the back of my mind, is this whole concept of naming convention and storage location. The environment you're working in, the RStudio environment you're working in, already manages that for you. You don't have to think about it.
That would be interesting, yeah. Because, you know, there are different ways of sharing information. Like you could just share an output as a graph, right? And that's, you've done all of the work and that's what you're presenting. But, you know, in terms of someone, yes, they would want, I guess, parts of the code, they could rerun it as long as they have the same environment, you know, and all of the same packages and all of the things, and then that would be the same. But I think it's an interesting thing, because there are certain things with analysis that sometimes take hours, you know, and I would not want to rerun some of those steps, definitely. Or if someone shared it with me, I'm like, just give me the object, or at least this cache thing, so that I can just use that.
I was also, I also wanted to add on to Becky's statement. So not all Markdown formats are treated equally. And the statement I made in our messaging was that GitHub, GitLab, different rendering engines, we'll call them, they use different syntax for their for their Markdown. So you have to be very careful on your authoring special characters like ordered list, unordered list, bullet statements, tables. You want to maintain that certain base protocol so that all of the various engines can render it. As you branch off into unique points, another rendering platform may not recognize what you're doing. And I'll give you a use case of this thought process. So Mermaid Js is a way of authoring these really awesome graphics, right? Vector graphics of, flow charts or any sort of linkages, et cetera, swim lane diagrams. In RStudio specifically, that's managed by the diagram R package. Some people will call it diagrammer. But if you just call a mermaid object in Markdown and it does render, some instances I notice that it works. In other instances, I just get a code block that has my garbage there without actually rendering the object, visual object, graphical object. So that's another thought to always keep in mind. It's not you. It may just be the environment that you're working in. I did want to add one more piece to this, and I've only learned about this week, so it's not anything special. But Quarto is another service that we're talking about. It wasn't referenced in our R4DS book, but it is in the future of RStudio's thought process. Quarto is the new equivalent of our Markdown utility, and it is going to leverage a lot more dynamic details, and it's going to work with other formats. IPython or Jupyter Notebooks is the other term for it. Let me see if I can get you that link as well. Isabella is one of our members in the Python, something PPP is the name of the book club, something Python. The reference we were asking ourselves were, how do we share our information? If we're not going to use RStudio because it's going to be authored in a different language, Python in this case, how do we share in the same manner that we would in our RStudio book clubs? And the reference was she made was, can we use Quarto and be able to render in that library instead?
Okay, thanks, Federica, for the link. I was just reading. So they were saying essentially caching is like saving and reloading objects. And I was like, okay, that makes sense to me. I guess the other question I had, and this is just in general for you guys in the know, do people use Markdown more or more Jupyter Notebooks, or is one preferred over the other, or what are your thoughts?
Both.
Everything, all of it.
Okay.
Yeah, it depends on your development environment or the collaboration you're having with others, what their common language would be as well. You'll find as you're working with users, they may be agnostic to a language versus somebody that you're working with says, I only recognize this form. So being able to work with that other user in that format. If it is Jupyter Notebooks, go for it. Not really good with version control. Jupyter Notebooks they get a little bit wrangly in version control. If the RStudio environment and our Markdown is your choice, go that direction. So, good question.
Okay. I guess I've had both cases. So at Berkeley, the Jupyter Notebook is very, very popular. And so I'm wondering if that's getting more adopted, or maybe it just seemed like that to me because I work with a lot of people at Berkeley, but I also get a lot of, just like R scripts and Markdowns from collaborators. So.
Yeah, if you think of data science in general, you've got your database admins, your SQL language type manipulation, Julia population, RStudio population, and Python population, all of which is like everybody has their own language of documentation that they author in. The comment of Markdown is intended to be agnostic across all forms of those languages. You can render Markdown in any one of those. If we start to communicate in R Markdown or in IPython, the Jupyter Notebooks thought process, they're going to render, or you may run into conflicts with your current working environment versus that of another person that authored that book. So your environment that you're authoring in, though, will still use the same common Markdown formats, though. So your references and your bullet statements and your heading levels and that kind of nuance, code blocks, all of that's going to be common throughout all of those various languages. So keeping that in mind, you should be familiar changing different languages of data science in general.
Right. Makes sense. I guess I just have one extra random question. Has anyone worked with SnakeMake? Ryan?
Immediately, SnakeMake to me sounds similar to like a Python library of like old stuff, maybe. Looking it up real quick.
Okay, because I'm trying to work with it and have many questions, and so in case someone haven't worked with it.
I will check this out, Sandra. Most
Awesome.
of the
Thank you very
languages.
much. I don't want to bother you unless you're interested in looking. I don't think it's specific for bioinformatics. That's where I'm seeing it used. It's essentially for reproducibility in terms of workflows. So that you're using the exact same version and handling all of the incoming data in the same way, and then you can get down into even generating specific types of graphs, because there's very common pipelines that are used for certain types of analysis, and it's nice to just have a standard way of sort of putting all of those together. So
I was going to be forward and just say anything related to Anaconda or just Conda in general. I'm often usually saying, no, I'm not going to go down that rabbit hole. Conda as a package management for Python is really, really, I'm being careful because I sound opinionated here. Conda package management and environmental variables within the Python language can get really, really spaghetti messed. By just saying don't use Conda and staying outside of that environment may actually help you in the long run. I would say the same thing with Homebrew on a MacBook or any other package management platform. You always want to be careful because they have a very unique way of doing their own business, and it will conflict with other thoughts that you're running down. I haven't messed with SnakeMake yet. I'll check it out and see what I come up with.
Okay. In terms of Conda, I could be wrong, but I feel like for our packages, not on my my own desktop, but like on the cluster, that's like the tool of choice for environments and everything. So I think unfortunately there is nothing else. It has its issues, but yeah, I mean I don't know a whole lot other than it works for what I need to do. And okay, I see Federica on the chat. Yeah, that's exactly the part that I was reading from the link that you posted. So, but I'm guessing that then caching has some benefits over just saving and reloading an object, right? Given that you can actually modify some of these inputs to the process that whose result you cached, right? And that's what made me think of this SnakeMake, because I think SnakeMake also does this sort of comparison to things that have been generated. If something has changed, it will regenerate a specific report that was, coming from, say, like, this very large CSV or whatnot, for that example. changing our sessions in the cache. Okay.
Here, for example, it says you will often think of caching as something valid in only one R session, but we will see it can be persistent across sessions via storage on disk. So you can retrieve your caching things in the next session.
Right, right. Okay. Okay. Yeah, I guess the word that I was looking for is it seems more flexible than saving and reloading because there are options that you can set. I mean, just from, first pass looking at it. Thank you. That's helpful.
Okay, I'm gonna get going.
Okay.
Yeah, it's nice
Awesome.
to see
Thank you so
all.
much for answering questions and for the presentation, Becki.
Yeah, thanks. See
Thank
you
you.
all next week. We are meeting next week, right?
Yes.
Okay. See you all next week.
Okay. Bye.
Thanks, Becki.
Bye.
Thanks, everyone.
Bye.